Now we have one last method for learning how to solve a quadratic. Again, this is a method that will always work. The good news is it's going to end up being a little bit easier than completing the square. So now you say, well, why in the world did you teach us to complete the square if you're going to teach us an easier method? And I have a very good reason. Okay? Because you actually complete the square to find the formula. So really, they're the same method, it's just that the formula does most of the work for you. So, we're going to complete the square on a perfectly generic quadratic equation. The first step was to divide out by that number in front of the x squared. The second step was to kick over the constant term. The next step was to figure out what d was. And if you remember, d was always this number divided by 2. So it'll be b over 2a. And then what I added to both sides was what I got when I squared this term. Okay. Now it's getting a little bit messy, but we know these steps. I'm just doing them with letters instead of numbers. This left-hand side always factors as x plus d, quantity squared. Now the right-hand side, I can add these fractions, and I end up with b squared minus 4ac all over 4a squared. Okay. Now, taking a square root of both sides, gives me this. And then I'm finally going to be able to get the actual formula, which that if you have a perfectly generic quadratic, the x that solves it is minus b plus or minus the square root of b squared minus 4ac all over 2a. And you notice, all we did was complete the square. Now, a couple things about this formula. First of all, if you remember back to warning number 4, in order to use the formula, you have to have an equal to 0 on one side. You cannot start using the formula until you have that. And we have a new warning, warning number 6, that you have to be very careful when you use the formula about the fraction bar. Because the most common mistake is that people don't have this fraction bar go over the whole thing. So they end up with something like this. Do you see how these are very different things? Because in this one, the divided by 2a isn't on the minus b part. It's only on the square root portion. So these are not the same thing. You have to be very careful about your fraction bar. Now, another interesting thing about the formula is this portion inside the square root. This is called the discriminant. Now, to discriminate means to decide between or to segregate. And what this discriminates between is how many answers you're going to get to your quadratic equation. Okay. If this number, the discriminant, is a positive number, you're going to have a square root of a positive number, you're going to get 2 real answers. If this number is 0, you're going to have negative b plus or minus 0, which is just negative b. You're going to get 1 real answer. And if this number is negative, you'll have a negative inside the square root. You're going to get 2 complex answers. So just by looking at this, you can at least decide what your answers are going to look like. Now let's do some examples. Okay. We look and we make sure that it's equal to 0 on one side, because you can't use the formula without that. This one already has that, so now I have to figure out how to plug into my formula. In this case, my a is 2. My b is 3, and my c is negative 5. The numbers that we call coefficients in front of each term. So I now plug into the formula. X equals minus the b plus minus the square root of b squared minus 4 times a times c all over twice a. Again, be careful to make your fraction bar look nice and long. And now we just have to clean it up a little bit. Negative 3 plus or minus 9 Now this minus 4 times 2 is minus 8 times minus 5. Well, 8 times 5 is 40, so that's plus 40 all over 4. 9 plus 40 is 49, and we happen to know the square root of 49. So this is really negative 3 plus or minus 7 over 4. And we get two nice pretty answers. Negative 3 plus 7 is 4. Divided by 4 is 1. Negative 3 minus 7 is negative 10. Divided by 4 is minus 5 halves. Those are my two answers to the quadratic equation. This one, I again identify my A, B, and C, and I plug them into the formula. X is minus B plus or minus B squared minus 4AC all over 2A. So here I have 25 minus 20, and then all over 2. 25 minus 20 is, of course, 5, which does not have a square root. So my final answer is 5 plus or minus the square root of 5 all over 2. All right, do you remember what I said we had to do before we use the quadratic formula? We have to get an equal to 0 on one side. So before I can do this problem, I have to subtract the 10x over, so I get that equal to 0. Then I identify my A, B, and C, and plug into the formula. X is minus B plus or minus the square root of B squared minus 4A and C all over 2A. So I get 10 plus or minus the square root of, well, this is 100 minus 20, or 80, all over 10. Now, square root of 80 can be cleaned up. It is 16 times 5. So we get 10 plus or minus 4 square root of 5 over 10. Now, you're not quite done yet. You can clean this up. But you have to be very, very careful how you simplify terms you get out of the quadratic equation. I can't just cancel the 10s because of the plus or minus there. I can't just cancel part of the 4 and 10 here because of the plus or minus. What I have to do to be able to simplify this is say, what do all three terms have in common? And in this case, our three terms all are divisible by 2. And so I can divide them all by 2. But I have to divide all three terms by that 2 in order to simplify correctly.